end of last semester. And he's going to tell us about his work that he did for that dissertation. And if I could just summarize it in too tersely, I'll just say that Keith was motivated from the very start about having studied, being a specialist on regional economics, motivated to ask the question, when we have a very skewed distribution of city sizes, and you have a very skewed distribution of firm sizes, what is the interrelation between those two clear social phenomena? So he's going to tell us about that. Or
I don't do clapping well.
Neither do we.
So this is a nice feedback we have going here. So I'm a geographer. I consider myself a geographer. By training, I come from geography background, and so my master's thesis was on migration. So I came to this, I was lucky enough to sit through a talk by Dr. Axtell in Hilton Root's class, of all places, and came out and took a class here and ended up basically doing an extension of my master's thesis using Dr. Axtell's model. So basically what we're going to do is we're going to get people to migrate among cities. We're going to motivate it with the firm formation model. And I assume this crowd is all familiar with the firm formation model. I'm going to go through it briefly to make a couple points. So bear with me. I know some of this has been discussed before. So starting out with an empirical observation is that we cluster in space. It's kind of an odd thing, actually, when you think about it. You know, we have in the U.S., and this is primarily relates to the U.S. Context, we have this huge country, and we tend to sort of clump together in really small areas. And one thing I was noticing yesterday, West Virginia is basically non-existent. Like, it's kind of bizarre. It's actually very pretty, but there's just no light there. You know, there's not much going on there.
You're saying it's North Korea?
Yeah, actually, I was going to say that, but decided against it. So I mean, this is sort of odd that we do this, and we choose to do this because you know, once we build a wall down here, migration happens mostly within the U.S. You know, sorry. But the other thing I want to point out, other than the clumping, is that the biggest city and the second biggest city are about as far apart from one another as they possibly can be. The third largest city and the fourth largest city are about halfway between, and then they sort of pull out to the edges. And the fifth one is a little weird. Or the fifth one, maybe we're fifth now. I don't know. DC is very top. But so when we're thinking about cities, I'm thinking about metropolitan areas. Although we clump, these things spread out pretty far in space when given the opportunity. Other countries are somewhat different. England tends to be more centrally located. Mexico City is pretty in the middle. But then the bigger cities tend to go out towards the edges. Taking this to a stylized end, you end up with something like central place theory, where you have the largest cities locate the most distant from one another, and then filling in are an increasing number of progressively smaller cities. If we just take this, and you know, this is still in space, so this is still in sort of geographic space, and we strip out space, we end up with the Zipf distribution, which you are all familiar with. Sort of as a footnote, the Zipf distribution and central place theory can't both exist because you have a hierarchy of goods in central place theory, where the second, so you have, this is all based on, anyway, these things can exist simultaneously. But nonetheless, this one is very place to start when we're trying to replicate cities. It happens in most countries across the world, that when you take the log plot, scatter plot them, and take the slope coefficient, you end up with a slope coefficient of -1. These things deviate from, to me anyway, firms. The second firm is about the second largest firm by employment. The phenomenon happens at the firm level. So what we're going to do is we're going to try to develop spatially Zipf distributed cities. So although Zipf's law doesn't exactly conform, it gets rejected pretty frequently in time and space. The slope coefficient isn't exactly 1. It's a good first approximation about how we distribute ourselves in space. Central place theory, although it's not strictly empirically observed, even though it's like super difficult to test, I find it to be a good approximation, a good second approximation, I'm sorry. And although it maybe is not still in time, it develops slowly. We have, in the US, we sort of migrate to the north and then we go back south, depending on whether or not we've invented air conditioning and things like that. So this is the goal. So we're going to try to develop spatially distributed Zipf cities. So what have people done on this topic so far? Nobody has been interested, for the most part, in the geographic component of this, and I'll get into that a little bit. But for the most part, there's two different types of models. You have stochastic growth models, which are just random growth models, and we can justify the random growth processes through amenity shocks, preference shocks, or productivity shocks. And so through each period, each city grows just like a little bit, randomly, unrelated to the last period and so forth, based on just some underlying theory that we can use to justify it. The problem with this is that for the most part, even if we say it's amenities or preferences, there's not really an underlying theory, it's more of a model. So you're just taking the stochastic growth process and just applying it and then using something to justify it. The second set of models are economic models. These can be characterized, or I characterize them in sort of 3 subcategories. And these are regional application of national growth models, models of new economic geography, and urban economic models, with one exception that we will get to in a bit. For those of you that remember macro, there's these endogenous growth theories. There's a bunch of them, but for the most part, the 3 big ones are the Lucas model, there's a product variety model, and then there's a quality ladder model. So all of these basically try to take some sort of output, and we're gonna take a fraction of the output and use it as an input, and this sort of drives the model forward, which is why they are endogenous. When we apply these to a regional level, what ends up happening is that basically my take on it is that these become stochastic growth models. We're just washing them through the filter of an endogenous growth model. So we're just saying, due to some underlying growth process that has, maybe in one period we grow a little bit, in another one we shrink a little bit. It basically becomes a stochastic growth model. The second set of models are the so-called new economic geography models, and this was kicked off by Krugman in 1991. And these models are all based on consumers' love of variety, right? So what we're going to do as consumers, we are going to try to maximize our utility by, basically getting the largest amount, the largest variety of goods that we can for the minimal cost. What's nice about these models is they do have some feedback built into it, where we can spread our labor out. It's typically done in 2 cities. So we're going to break labor apart into 2 cities. And some of labor is mobile, other parts of labor are not mobile. And as one city grows, firms have an incentive to migrate there. So the firms shift. Because they're operating under monopolistically competitive environments. So what they're doing is they're trying to differentiate well, I mean, they have a unique product, and when labor is trying to maximize their utility, they're trying to get as many varieties as they can. So what ends up happening most of the time is you have all firms ending up in a single city, so that they can basically reduce their transport costs. It's a super popular model, and this is possibly my favorite quote in any academic paper. From the outbreak of the epidemic, it was clear that the empirical evidence was weak. Basically, there's like no evidence that anything this model predicts works. So, and like there's whole books written on this, and it's insanely complicated. And to balance the model it takes a lot.
Just to be clear on the quote, Keith, Brilliant saying that new economic geography is the epidemic.
Yes. So yes, and he takes actually a lot of issue with this model because I mean he talks about how, you know, because this got so popular, like the model's popularity. I mean it's basically a preferential attachment model where students would view this as the only publishable work, so then students would try to replicate it, and so like it was sort of a mini outbreak. We've infected a lot of people with it. The last set of models started with Henderson in '74, and what Henderson does is you have workers that are producing under constant returns to scale. All labor is in a singleton firm producing under constant returns to scale. There's local within industry economies of scale. And so what this does, right, so if I'm producing water bottles and I live in the same city as somebody else who's producing water bottles, we each get a productivity premium. What happens in this model, the outcome of this model, is that all of the cities become completely specialized in whatever product they're producing. So you have one city producing water bottles, you have another city producing computers, and the size, so the way that these guys get the size, the city size distribution to shake out to the Zipf that we see is by basically giving different products different economies of scale. So, you know, the problem with all of these models is that they make three basic assumptions that are all interrelated to one another. They all assume constant returns to output at the firm level. And then they have increasing returns at the city level. Okay, and stop me if I'm not making sense. The issue that I take with this particular assumption is, why are we aggregating to the city level? Basically, what you could do is take all of these models and rename the city a firm, and then it would be a firm model, right? So we're all producing under constant returns to scale. If we get together, we produce more together. We've literally just renamed the firm model a city model. It doesn't, I take some issue to that. The next two are entirely interrelated. The two, starting with the number of regions, so this leads to the second one. So the first assumption that you can make regarding the number of regions, or number of cities, or whatever you want to call it, we can either hold them constant, or we can allow them to grow and die. If we're going to hold them constant, we have to make an additional assumption about whether to say that the city has a minimum population, right? So imagine we have 10 cities, and we have 100 workers. We evenly distribute them at the beginning, so there's 10 workers in each city. If workers start to migrate out of a city, and one of those cities gets to population 0, it exits the choice set. To combat that, we say, okay, there's got to be a minimum population allowed in the region. And this is what the NEG models do. And basically, this is typically justified saying farmers. So there's got to be at least one farmer in each city, so that that region doesn't exit the choice set. The second assumption, which is possibly more objectionable is we have infinitely growing populations, and once labor enters a market, it never dies and it can't live. If we don't make either of those assumptions, we can assume regional birth and death, and this, so workers are allowed to leave, but then we have to make an assumption about how regions are reborn. In all of the models that look at this, the assumption is that a new region is created. So this would be equivalent, in my mind, to finding new land. So literally a region dies and it's gone forever, and now to make sure we have our nice skewed distribution, we have to introduce brand new cities that never existed. And so this gets into migration costs. This one directly leads into this. If we assume a growing population, what they all do is they basically say there's no migration once you've entered the model.
So your last point about region death.
Right.
So if you were to the power law shape or the Zipf shape of the distribution for cities wouldn't change if you removed.
No, but they completely exit the. They're no longer even counted as city.
Okay.
You have to have somebody in it for it to be a city. Like somebody has to live there for it to be even counted. Do you see what I mean? So if imagine you have 10 cities, eventually what ends up happening, if you don't assume a minimum population or a city being reborn, you get 9 cities as somebody leaves, and 8 cities, and 7 and 6, 5, 4, 3, until you only have 1 city left.
But you've constantly got smaller cities that are also growing if you're talking about something like a proportional growth model, right? So a city can exit, you don't need to replace it through a kind of a non-organic process.
But that's equivalent to saying a firm of 0 workers. So the firm of 0 workers would never be in that distribution because the firm has died. It's exactly equivalent to firms. Once that firm dies, it gets removed from the distribution because it's dead. So if we assume this one, you can say there's no migration after entering. So if you have a continuously growing population, which is sort of what you're referring to, you say that the agent enters the region, he's never going to die, she's never going to move, and so that's an infinitely growing population. The other one, and this is all of these models assume migration, so the ones that allow basically interregional migration somehow, because it's not migration per se, they're just shifting labor around costlessly. It's without cost, literally. So you have these processes developing, and a perfect example is this. Yeah, is this one. So what Duranton does is basically you have an innovation process, right? And so this innovation process is you're constantly kicking out new innovations, right? And so each innovation is tied to the city that it was innovated in, okay? And so basically what ends up happening is through time, each city accumulates innovations, but it's equivalent to a stochastic growth process. It's just been washed through this blueprint format, and so at the end of it, we just costlessly distribute labor based on how many blueprints or the share of blueprints that each city has invented. So you just kind of like distribute labor at the end. There's some underlying process that's occurring, and then we're just going to costlessly distribute labor at the very end, not really question it. There's one single exception that I'm aware of, and it's the most recent paper that I know of. It only happens at the very end of their paper, and it only happens in simulations. So this is an equilibrium model, so it's primarily math. at the very end, they say we're going to simulate some of this, and the only way that they get sort of migration costs to occur is they force the worker to leave the system and then re-enter, but at that point it's like, well, why? I mean, that's equivalent to killing the agent and then reintroducing him. And one thing I want to point out right here is that if you're allowing labor to migrate, so you're letting firms being born and die, or regions born and die, you're just reallocating labor. You're just shifting the people among the different cities. This is the U.S. labor force. It's grown dramatically since 1948, but since the early 90s, it's really started to taper off. It's ticked back up a little bit recently, but it's been basically flat for the past 10 years. Outside of sub-Saharan Africa, populations are below replacement rate. So we can't really use models that assume constantly growing populations, I mean, among other things. So in my mind, we have to come up with a model that works under numerous settings, but particularly basically a flat population. We're just going to reallocate the population around. It's pretty wild that even after 30 years of basically no labor force change, the world's still sort of Zipfian. And as one final note, and I'm not going to go into this, this is where I'm from, there's a very large body of literature relating to migration. There's just an enormous amount of migration models, empirical data. One of the earliest one, which is the human capital theory of labor migration, almost uses, it's a descriptive model and it's very theoretical in most senses. The way that Larry Sajstad, I think is his, I know it's his name, I don't know how to pronounce it. He almost uses agent-based modeling language. Like he talks about, it's very micro-founded. It's difficult to ignore this stuff, but somehow all of the economists who have worked on this have done just that. We've just completely ignored migration costs. And before we jump into the model that we're gonna examine today, I'll just summarize it in this chart that it's basically going to be a feedback effect of new firm formation is going to lead to in-migration. In-migration is going to lead to firm formation, and round and round we go.
Also, a little bit about, just refresh us on when there are data on migration, it's resolved at like the county level, the zip code level,
well, it depends on what data you're looking at.
How often is it updated? What kind of quarterly flows, annual flows?
Annually. So there's two primary data sources. There's IRS county-to-county flows, which is updated annually.
Is that residential or is that local?
That is kind of both, because it's both the number of filers, but then also the number of exemptions. So you could say it could be the worker, but also his family or her family. And then there's the PUMS data, which goes down to very fine geographies, but the variance tends to be sort of big on that as far as the confidence intervals are concerned. But it's definitely, and this is something that we've talked about, inner firm flows, so like job quits, and if you leave one firm and go to another firm, are drastically higher than migrating. So you are 10%. It was last. I haven't gotten back around to it. Basically, for every 10 people who switch firms, one person migrates to a new city. In my dissertation, I talk about Schumpeter and Myrdal and all these other people. It ate up a lot of my time. Actually, this turned into like 4/5 of my dissertation. It was supposed to be half. I also did a survey for the other half. This was way harder than I anticipated it to be. I think at my dissertation proposal I said that I was going to be entirely done with the model. I defended in May, and I said I was going to be entirely done with my contribution by August. By August, I had barely replicated the underlying model and started to have a glimpse of how little I knew. I'm still struggling with that. I don't have to make this case presumably to this crowd, but I'm presenting at the EEA conference at the end of next month, or at the end of this month, I guess. So I'll have to make it to them. Issues with current approaches, they all use constant returns to scale at the firm level, backyard capitalism. We're all producing cars and computers because there's no incentive to cooperate. Unless you live in the same city, then it's all great. They're all equilibrium models, so they have a really difficult time dealing with increasing returns to scale. Maybe you have micro foundations at one level, but you lose it at another, and they all lack geography and therefore migration costs, which is my personal pet peeve. Agent-based modeling, we can easily incorporate increasing returns to scale both at the firm level and at the regional level. They're inherently non-equilibrium in nature. We can have micro foundations throughout, and we can incorporate geography. I'll go through this quickly, given the crowd. Dr. Axtell's model of endogenous firm formation, sort of the highest absolute level pseudocode. We're going to instantiate agents initially in singleton firms, and those firms benefit from increasing returns to scale, so we produce more together than we do separately. In each period, we're going to activate 4% of the population, and each one of the agents who gets activated looks at their current firm, decides how much effort they want to contribute based on how much they get out, and these agents all have heterogeneous preferences for leisure, so we all have different preferences for leisure. We have different endowments. We have different social networks. And then, so we're going to look at our current firm, decide how much effort we want to put in. We're going to look at the firms of our friends and decide how much effort we would put in their firm. And then we would decide our own firm, and then we sort of move this, and then we move to the firm that provides us the highest utility, not necessarily income. It's a utility maximizing model, not a utility, because we all like different levels of income. What does this look like through time? I should choose different colors. In T, say we have a firm of 4 region, we have a firm of 4 agents and 2 of 2 agents, so each column is a firm. The purple agent starts their new firm, orange joins the biggest one, and blue stays put. It's balanced on sort of 2 competing forces. We benefit from increasing returns to scale because beta's over 2, or beta's over 1. So we produce more together than we do separately. But we also decide how much effort we want to put in based on how much effort the other agents in the firm are putting in. So these things really spin back into one another. And we can decide to put in less effort because we're not being perfectly monitored. Nobody's watching us, so we can decide to take off at 2:30 in the afternoon and come give a seminar unpaid. I told my boss what I was doing. So it's sort of balanced on this. You play it out in time, and you end up with a Zipf distribution of firm sizes. And we also end up with constant return. Well, I haven't done this. End up with constant returns at the aggregate, despite having hard-coded in increasing returns in the firm level. So we've hard-coded that in, and we still get this result. So this is now getting to my time frame in life. This was August 2017. I replicated the underlying model using Python. This is about 100,000 agents because my code is drastically less efficient. I cannot parallel compute because I'm using Python.
That's not true. You can do it.
I haven't gotten there. So, we've replicated it. Now what we want to do is make our cities. I left off one model in those models that I reviewed earlier. Dr. Axtell and Richard Florida tried this in 2006, which was unbeknownst to me for the first 9 months that I was working on this. It was the fastest I've ever read a peer-reviewed paper, because I was like, yep. And basically what we're going to do is we're going to distribute the endogenous information model among regions on a lattice, okay? And so going back to our columns, these are two regions. Polygons are regions. This is the same game. We're just going to play the same firm. We're going to activate 3 agents, and then in T+1, the purple agent decides to start their own firm. The orange one moves to the second region, and then the blue stays put. The underlying model is built on a job search model through social networks. And this gets back to what you were talking about. This region now has more. They start out evenly distributed with 6 in each. This one now has more. Not only does it have more workers, it has more social network attachments, basically. So this one has a bigger social network. So because that has more sort of pull in it, it basically becomes a preferential attachment model. Well, not basically. In some ways, it becomes a preferential attachment model. That second region is now more likely to be chosen than the first region, simply because there's more people in it, so it has more connections. So if you just play this out in time, eventually this region, one of these two regions will die, and then it exits the choice set because nobody lives there anymore. And that's specifically because when this agent decided to start their new firm, they started it in the same region. If we make that assumption, one of these regions will die. The assumption that Dr. Axtell and Dr. Florida made in 2006 was with some very small probability, 1% or so, this agent is going to start a firm in a random region. So say we have 10 regions. With 1%, we're just going to pick a region at randomly, and then so it keeps all of the regions in the choice set played out through time. I make a slightly different assumption, which I think makes it a little bit of a difference. The 3 things, and so starting from this as a base, I add 3 things. Migration costs, congestion costs, and an urban wage premium. The migration cost is all it is. It's a linear cost as a fraction of the total distance you could possibly travel, right? So if you're traveling, if the maximum distance you could travel is 10, and I travel 10%, I'm traveling 10% of the max cost, so 1 times whatever weight I add to it. I don't have a good way of explaining it, but it's just a linear cost. The congestion cost that I have is weighted between productivity and scale. So basically you can think of this like rent, okay? So more productive places like San Francisco, or even smaller places like Charlottesville or Ann Arbor, the more productive you are, the higher the rent is going to be, because we're all bidding up basically our apartments. And it's like, unless we can build them, that has some issues regarding mean reversion, so I have to add in actually like a pure scale equation. So just literally as the city gets bigger, we're going to add congestion. And this goes into, you can just think about it like more traffic. It's like they want to expand 66, but as it goes through Arlington, you can only get probably an extra lane on each one. At a certain point, the city starts to solidify. So this is a combination of productivity as well as scale. And then we finally have to add in an urban wage premium, because if we've just added in this, the increasing returns to scale is only occurring at the firm level, right? So we're only more productive if we're working in the same firm. If we add in congestion, we're now incentivizing people out of the largest city, but there's nothing to incentivize them back in. The issue with that is that there's a very robust literature that bigger cities pay more. Although, apparently at the Atlanta conference, what's his name?
Otter.
Yeah, Otter. Presented a very well-received paper saying that the urban wage premium for less educated people has declined for the past 30 years. I haven't read the paper. Whatever. There's a pretty robust literature saying bigger cities pay more. And basically the argument is they pay more because they're more productive. So I add in an urban wage premium, and the more I think about this, the more I'm curious as to how this needs more thought. Basically what I do is I just shift the distribution of the increasing returns parameter. So these are drawn from some distribution, and all I do is just based on like bigger cities, it just shifts to the right, it just gets bigger.
Are you assuming the same thing for firms as well? Bigger firms pay more?
We'll get back to that. The beta, the productivity of the firm is shifted. So the draw gets shifted. So that's literally what's happening is firms, their productivity is being shifted based on how big the city is. So the differentiation here, so this is just like the running part of the original code. We're going to activate some set of agents. We're going to look at our current firm. We're going to look at firms in their social network, and then we're going to start their own firm. When we look at firms in our social network, we're going to subtract off a migration cost to moving to that region. This is a really strong assumption in the way that I have it coded in right now, because what it does, imagine you lose like $10 for migrating. You literally lose that $10 for the entirety of, until you get reactivated. I mean, migrating is a one-time cost, so I probably should be discounting it, but there's other issues with that, so I just left it simpler. I also subtract off congestion costs. And it's based on the firm. So whatever income that I'm getting from the output of the firm, I subtract off migration, I subtract off congestion. This is where it gets slightly different from the original emergent cities model is I'm only going to consider it. So if I decide to start a new firm, you randomly draw which region it's going to be started in, but you only consider starting it in that region. You don't necessarily have to. It's just an option. It's not just automatically started. And the reason that this is important is because this is where I provide the agglomeration productivity premium. So when the new firm starts, and this is to your question, I shift the distribution that the firm productivity is being drawn from based on the size of the city, and then it carries throughout that firm throughout its life. So if the city shrinks, the firm stays. It holds its productivity of when it was birthed, and then we do the same thing. We switch to the firm that provides the most utility. Okay, we're almost done. These are two different runs. So split here. If we raise migration costs enough, nobody moves. So each one of these lines is a city. Literally nobody moves. This is our lattice. None of the cities change. They all stay the same size. This is not Zipf distributed, despite sort of it kind of looks like it. But if you look at the scale, it's not even close. Once you lower the migration cost down to like a reasonable level, you start to get a distribution of cities that pushes out towards the edge, because people, every time you move, you have to consider how far away you're moving to. So we're starting to get some geographic dispersion, and it's very steady. This is something that I'm working on right now, is sort of putting confidence intervals around this type of stuff. But I have to make my code more efficient first. The next step is to add in congestion, and so this is a small congestion cost. So this is rent. So this is like 1/3 the max congestion cost. Anyway, basically the point here is that this is a really low congestion cost, and it's based entirely on productivity. But as workers migrate into your region, what you end up getting is like this mean reversion, where less productive workers show up into your region, and then they actually bring the productivity of your region down. So then actually the rent cost actually dives back down towards the system-wide mean. So basically, it brings the congestion cost back to zero, because it's matched the system average. There's no deviation. And then everybody ends up in one city. So it's like, well, that didn't work out. And this has also got super low migration costs, so people can just shift around all the time. And all the little cities, all that is basically that random allocation, right? So every time we start a new firm, like 1 in 100 firms is started randomly. These are all those random firms that start, and then all the people end up back in the big city. We raise rent a lot to like 90% of the wage, and you can crush the biggest city. This is 2,000, and so this is the population of the city. So each one of these lines is a city. This is 10,000, so this city gets to 10,000, whereas here I can keep it down to 2,000. But if you lower the migration cost, and right now it's 5, you see a different pattern. So basically what we're doing is we're using combinations of congestion costs and migration costs to get different city sizes and to get different spatial patterns. Sort of same thing here, but all I did was raise migration costs, and we can push the cities back out to the edges. Oops. If we add in our urban productivity premium, right? So bigger cities pay more, so we're going to make cities that we're going to make firms that show up in big cities more productive. It's really easy to get everybody to agglomerate into a single city. If you just make it high enough, it's just like, well, it's just sort of, that's where everybody's producing. Fiddling around with this and changing the parameters and basically just playing with it, I can get the whole system to stabilize around something Zipfian-ish. Qualitatively Zipfian. Where the second largest city it's too small in this run, but it starts to stabilize. Basically, you have one city, one big city, one half city, and then a lot of smaller cities, and they're spread out in space. So they really start to, we're getting both a stable distribution, but also we're pushing cities out towards the edges. So this is really exciting, except for the fact that this is this is stopped. So what this implies is nobody's moving anymore, and for our purposes that's a problem, because even though the distribution doesn't change through time, migration doesn't stop. So that's actually a problem. Another problem is, and the Zipf coefficient is not right, or close. Another problem is that if I just simply add more agents, the whole thing collapses into a single city. So it's super sensitive right now. However, I'm fairly happy with the fact that I could get something even close. And so, we can, I do think we can use firm bursts and deaths to explain the Zipf distribution of labor within a system of cities. It's kind of a holdout for my dissertation. Zipf cities aren't necessarily dependent on Zipf firms, because one thing I haven't really talked about is this is more of an establishment level model, because what we've done is we forced all the workers to live in the same city that they're working in. Well, that means that the establishments can't grow bigger than the city. And sort of current and future work, I'm scaling it up, which implies making the code more efficient. A lot of sensitivity testing, and then sort of in the very long run, I'd like to try to get some regional forecasting with this, because the way that regional economists do forecasting is has some assumptions that I somewhat disagree with. So I'm going to try to put like confidence intervals on what they're doing. Some selected citations, and any questions you have or comments are wonderful.
I'll start off. I'll tell you something that I think only Rob and I knew. When I told Rob, I don't think he believed it. But so, having had the access to the microdata at the IRS, ran a regression on the size versus wages paid by all U.S. firms over a period of 17 years. And what most people don't know is that that scales sublinearly. Okay, so the larger a firm gets, the lower overall the wages it pays. Now the assumption is that there is a firm size wage premium. Okay, that the larger a firm gets, the more it pays. But if you look strictly at W-2 wages, not including benefits, that doesn't seem to hold.
The distribution shifts within the firm.
Doesn't hold. So, and that's just what I know. We could discuss maybe some methodological issues, but that the wage premium assumption does not hold for direct wages, W-2 wages. Okay, so here's a hypothesis. It looks at like most of your scenarios tended to produce 1, 2, or 3 large cities. Okay, that's it. There seems to be no constraint on how large the cities get under most testing scenarios. Well, maybe because there is an incentive, since as the firm size gets bigger, wages decrease. Maybe there's an incentive, a constant incentive for workers to move to smaller firms. By that same analogy, maybe there is an incentive for workers to move to smaller cities. But right now all the incentive is because of the wage size premium and because of the city size premium that you're assuming in your model, there's an incentive for workers to move to larger cities and larger firms. But if you look at the size wage comparison, turns out there's at least W2 wages, there is no premium. So there's an incentive, there could be an incentive for workers to move to smaller firms and to smaller cities. That would eliminate constantly conversion to 3 or 4 large cities.
So that's why I incorporate the congestion costs. So it's purely just like how big the city is. I penalize your wage as the city grows. That's exactly what the congestion cost is meant to do. Is to try to incentivize people out of the largest city. Just be like, there's just too many people here. We all have to go downtown, and there's just too much traffic. So, although that being said, so that's what this is an attempt to do. That being said, I do not suggest that the way that I've incorporated it as it is sort of the most robust, or I'm not sure that I've incorporated my congestion in sort of the best way I could. It's pretty brutal. It's just like it's the log of the population times whatever coefficient that I can change basically to scale it.
Okay. Well, either way, the wage premium, I think I have to question it at some point, just as a basic assumption, because the microdata does not say that.
Maybe there are two ways to think about that, Joe. Maybe one is, I think the original regressions that are run by this guy, Charlie Brown and James Medoff. The original regressions were a little different than yours. The original regressions were controlled by job type. So you used to take only electricians or only plumbers or only accountants, and then there you find that controlled by job type with a bigger firm you paid. So you're in essence diluting everything, but you're averaging.
I'm including
overall.
CEOs. I'm including everything.
And so there, I wonder if there's maybe that would be just a different effect or something.
I think I had a similar thought that you commented during the urban wave framing that there's a competing, I guess, assertion that for the less educated, it actually there's evidence that they get less pay.
Yeah.
Is there an opportunity there to pursue a model to explore that paradox?
Yeah.
Perhaps there's a divergence in the model and two different applications or two different models required.
There is. I wasn't going to talk about this, but I guess I will. Yes, and so the basic story that I have to tell with that is that there's this guy Enrico Moretti out of Berkeley, and his big finding in 2004 was that more educated workers in a city raise the productivity of less educated workers. And so what you see is as the share of as a MSAs, as a region's, population, maybe, I don't know, PhDs, the percent of local population with a PhD goes up, you actually drag up the wages of people without a college education or without a bachelor, but it diminishes as you get higher. So we start to, his theory is that we start to compete, right? So we're making people in our city, the less educated, more productive. However, we're competing with one another. We still push our wages up a little bit, but not nearly as much as we do the less educated. Whoop. I'm trying to leave. It's very dry here, so I've been dreaming of going to an island, which is why I put that. I spent all of my time in the cubicle. And so my this is Endowment, right? In most of the runs, that's homogeneous across agents. They all get an endowment that's exactly the same. It's not distributed, it's just one, and then we subtract off our effort. This is super interesting because if we distribute that, right, and the more educated actually can have a higher utility. So, I mean, imagine all else equal, we raise this from 1 to 2, and we're subtracting off the same level of effort, you're getting more utility. Simply because your endowment to effort proportion, it changes, right? So because you're not putting in less effort, but because the ratio's changed, you sort of are. Which leads to... and I don't think this is going to be the thing that saves the model and makes it like bubbly and fun and so forth. But I did do just what you were suggesting, right? Whoop, lost it again. We're back in the island. So this is that sensitivity test that I showed. So we add in more workers, the whole thing collapses. If all we do is vary endowment, it starts to pull that back down because the more educated workers are less, basically they're penalized less for going to a bigger city. So there's absolutely a way to do that, and literally so this is exactly the same model run as this, but as all we do is vary endowment, we can start to pull that like Zipfian style distribution back in. We've done nothing else to the underlying model. But that being said, then you like sensitivity test it more and it collapses again. So
You said that you had excluded benefits with larger firms or smaller firms. Could the difference in compensation be primarily in benefits? Or could that rescue the curve?
I don't know. Maybe. An alternative answer, because I don't have an answer to that, basically.
Yeah.
Wow, I gotta leave this one. Go back here. So there's an interesting one of those models. I think it's the most recent one. Basically, when you add in these two things, this becomes like that Henderson style model, which they have increasing returns to output at the city level within industry. And so one of the most recent models basically, so this is my answer, not answer. If you have if you make the congestion cost and the urban wage cost both superlinear, so you're being penalized for being in a bigger city, but you're also being rewarded for being a city at the exact same time. And if somehow I can make these two things equal, for any given agent in any given job search, the reward penalization is going to be slightly different, and then it basically it's just noise. But because you can't see it, you would never find it in a regression. But played out through time, that noise, I think, is going to redistribute the agents out. You know, because at each time period, it's like, well, like I got this job opportunity, but because the researcher can't, because you can't follow it in the microdata, because you don't have forever timestamps, particularly this plays out generationally. So I think that's my saving grace. I'm not sure about the benefits. I'll have to think about that.
One more question?
We've got some online questions.
Oh yeah.
Somebody's watching?
Yeah.
Okay.
He says the challenge with the human capital theory is that it describes everything in financial terms, and those decisions are not purely financial.
So true. I'm assuming our web participant is talking about the human capital theory of migration. Could you read the question again?
Oh yeah, he says the challenge with the human capital theory is that it describes everything in financial terms, and those decisions are not purely financial.
Yeah. So I agree. That is one criticism of the model, is that this entire model is based entirely, it's couched in economics. There is currently no consideration regarding sort of how nice the city is. I'm originally from Michigan, and I absolutely love Traverse City. It's like super nice, and the saying there is view of the bay for half the pay, because it's super nice, but you're not going to get paid very well. And this is the distinction between the equilibrium and the disequilibrium model. So one of the things that I could do to sort of address that concern is I could shift the output. We could change that based on some sort of quality of life issue with the city. So every time a firm is born in a city, if it's a nice city, we can add as almost as income. And I think that's how I would address that. Is literally just calling this like, oh, like being in Colorado is super nice because it's sunny and we can go skiing. So we'll count that as income. Because I mean, you know, Detroit pays really high wages, basically to bribe people to go there. Places that have above average wages that are with like below average housing costs, it's basically a bribe to get people to come because it's not a great place to live. The best example is like oil rigs in North Dakota. You have to pay people like $80,000 to live in the middle of nowhere and it's like free to live there, but you know, not that many people want to do that, so that's why you have to pay them so much. So I agree with you.
There were other comments. Do you want to read them?
Sure. Yeah.
Yeah. He also said,
you're also welcome to leave. I know I'm not that entertaining.
I don't think the urban wage premium needs to be described by productivity. Urban areas pay more because there's more competition.
Yes, so that is something that I have recently had an epiphany on. I mean, this is basically Porter's discussion on cities are more productive because there's more competition. And I went down a very long road with this, and I gave up. I turned back and went back to the highway. One thing that I'm interested in regarding this comment is that you could basically look at the speed of firm births and deaths within city, and so if it speeds up within larger cities, you basically have more competition, which would produce the outcome or sort of deal with the issue that this person is suggesting. And I agree with the commenter fully. I actually believe it to be true, which is why I went down the road. However, there is a paper, and I don't think I have it, but it's by, I think it's by Duranton with some other co-authors, suggests that that is not the case, and that like it's actually being dilated up. The productivity is dilated up, and that while they don't suggest it's the case, they don't even consider that this is a possibility. I do believe that firm selection is basically happening, and bigger cities have a higher rate of firm selection through birth and death. But I never figured that out.
Okay, why don't we stop there? I think we'll be around for some more questions afterwards. And I think he's also interested in having comments about, you have to shrink this down substantially, I think, in order to fit it into your session at the end of the month.
Oh
right?
yeah, I'm not even close. I'm not sure what I'm going to cut.
Okay, thanks again.